All right, this is going to be Unit 2, Lesson 10. We are on the quotient rule today. Standard G, what is that class?
Advanced derivatives.
Yeah, advanced derivatives. Yeah, it's the only other one that we have. So F, then G. So let's talk about types of quotient. So what do I mean when I say quotient? Do we have in our minds what?
Division.
Division, yeah. So you can say division. The better word I would like to use is fraction. Maybe you want to write division down here too. Yeah, so we know what a quotient is. Perfect. All right, so let's look at the first type of quotient. One where you just have a blatant x on the bottom, so a function on the bottom. So all four of these are different types. You might want to write, I'll just write over here, 4 types. And these are the 4 types. So I have a function on the bottom. All right, so when I evaluate this, I get what? 3 divided by x.
Negative 3?
Oh.
Raised to the power of negative
yeah.
x negative 2.
Ooh, hold on. I think this type and this type are really the same thing. So maybe, okay. Sorry guys, I'm gonna change this a little bit. I apologize. Let's just make it some 3 over 7. Because this is the wrong type. This type and this type would have been the same. All right, so first type. d dx, the derivative of 3/7.
Wait, what?
I heard 0. Why 0?
Because there's no x.
There's no x? Yeah, what do we call these things?
Oh, that's spicy.
Yeah,
Starts with a C?
Constant.
There it is, Isabel. Yep, thank you. Constant.
That was Joy.
Oh, it was Joy?
For the video, that was Joy who answered, not Isabel.
Sorry, Joy. It came from this direction, and it's a direct line. I'm sorry. All right. So, number...
So you change x to 0 just
Yeah, I changed it in the notes, because otherwise it would have been the same type as number 3. I apologize. What about number 2? The derivative of this quotient.
It'd just be negative 5 over 4.
Negative 5 over 4. Why? That's 5 over 5, Mr. Sindel? Negative 5 over 4.
Coefficient.
Yeah, so you're just taking the coefficient. You're really saying that this was x to the power of 1. The 1 came down in front, times 1, and then gets subtracted. X to the power of 0 is... X to the power of 0
1.
is 1, so it's being multiplied by 1. So it's really power rule. So that's where the x went. It turned into x to the power of 0, and we got negative 5/4.
I think this is the longest you're using.
So
I'm gonna cut it.
I think the better way of writing this, can you squeeze in a d dx before this?
Okay, Leah.
The better way of thinking about it is negative 5/4 times x, and then when you take the derivative, that finally becomes the negative 5/4.
How do you spell coefficient?
I'll spell coefficient on the left-hand side over here.
Thank you.
I'll do it in black here. Coefficient.
Wait, I'm confused.
C-O-E-N.
Oh, I get it.
So what type is that?
Good job.
So what type is what?
Is that one?
Number 2, this is just where you have a function in the numerator. When you have a function in the numerator and a number in the denominator, all you do is you take the fraction and you take it out. So if it was just a number in the bottom, like, I'll give you another example. You don't have to write this down. I will leave it in the notes though. If I had like something like x over 4, this gets turned into 1/4 times x.
Yeah.
So you just pull out the fraction, and then you leave the function as the second piece, and you take the derivative of that function, leaving this. Remember how we always wrote a times cosine or a times all of our rules? This fraction would be our a. You leave it there.
Okay.
Okay, so our third type is when we have a function in the denominator.
Right.
Oh, yeah, you said cute. I was like,
Maybe I should box these, yeah. Our third type is when we have a function in the denominator and no function in the numerator. So how do we solve these?
You got the power negative?
Yeah, Joey has it. So make the power negative. So when it climbs the ladder or when it goes down the ladder, every time you go up or down, the negative and positive sign switches to the opposite. So this is going to be d dx of 3 over 2 still. And now it's in the numerator, is going to be, maybe I can keep it in the numerator up here, e to the negative x. And again, now that's turned into a type 2 question where you rewrite this as d dx, the derivative of 3/2 times e to the negative x.
So then it would be.
So what is the final answer here, guys? Girls, sorry.
3 over 2 times e raised to the power negative x.
3 over 2 times e to the negative x.
Because it's E, so it just
So it
stays.
just says this.
E house stays the same, yep. But
Then it's negative.
then it's negative. Why, Sophia?
Because you have to take the dinner.
Yep. In order to get dinner, the inner was negative x, dinner is negative 1. So multiply this by dinner and it becomes a negative 3/2 e to the negative x. Perfect. All right, now we have variables in the top and the bottom. So I have function on the top, function on the bottom. Okay, now what am I going to do?
Wait, what was that last one called? What would you call that one?
Function on the bottom, or you can say variable in the denominator. Maybe I should be writing these down. I'll change color to black. So variable,
In denominator.
I'm just going to say bot.
Bottoms up, bottoms up. Yo, my name is Sophia McGee, and I really need.
All right, so this one was variable top. This one was no variable.
It is recorded too.
Can we re-listen to that, please?
Yeah, on YouTube, sure, later. All right, so variable, no variable, variable on top, variable on bot, and this one is variable on top and bot. And on top of that, we can't get the variable on the bottom, the variable in the denominator. We can't use Rule 3's trick of getting it to the numerator. You can't take natural log to the power of -1. Well, actually, you could.
Don't try and make my sisters and I.
You could. You can always do that. But sometimes it just becomes really, really ugly to do so. This is a case where it would be a little bit ugly, but you could do it. It's manageable. In this case, you want to use quotient rule. I'm teaching you why we want to use quotient rule. So we'll call this guy, in quotes, this is quotient rule. And I remember being in calculus, and I hated quotient rule because I never remembered which one came first and which one came second.
The egg. Sorry, wrong egg.
Good one. So I would always make the denominator into a negative power, which you can always do, but there were definitely times in class I'm like, wow, I really wish I knew quotient rule because this problem is ugly. All right.
Obviously God.
So maybe it would also be helpful to write this guy out as, instead of saying variable, I'm just going to say function on top,
Can I put this in your trash pile?
Yeah.
function top, and function bottom.
So how about we say rainbow? Wait, that wasn't the term. What was it called?
Rainbow?
A magic fraction.
Magic fraction is something very specific, and it's when you're taking the limit as x goes to
Okay, never
infinity.
mind. Ignore that.
So the quotient rule is when you have a function top and function bottom. This goes with quotient rule.
Should we start this? This is important.
The next thing this is number 4 is the second most important thing in our notes right now. So if you want to start, you can. This is how I know when to use quotient rule. It's when I have a function on the top and a function on the bottom.
Wait, what's the first most important thing?
It's coming up in the next slide.
Oh.
All right, here we go. Quotient rule. Can I go to a new slide?
Yep.
All right.
Wait.
No.
Aren't we gonna solve it?
Oh, we're going to solve it down here.
Oh wait, but then can you go back afterwards?
Anyway.
We'll do it down here.
Just go solve it.
So this is going to be called the quotient rule.
The Done. Good.
Right here.
Wait.
Thank you, Kale.
Thank
You're
you.
so sweet.
Our boy.
And instead of saying top and bottom, what's even better is if we start calling it even shorter. What's shorter than saying bottom or bot?
Num and dem.
TB.
TB.
These are good ideas, and this one actually ends up sounding really cool, so I'm going to do it this way. d dx, the derivative of high
Low.
low.
That's
Yeah.
our league.
Oh my god! We're gonna be the champions.
High low. So what does this turn into? And I'll give you the rule that's really cute down here, but I'm gonna give you the textbook rule up here. And here comes a star.
Here comes the star. That was a good one.
Here comes the star. Do 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 do.
That was like such a magic moment.
It's really the sun, but okay.
I know, it really was.
So if I take the derivative of a function, and usually our functions are represented by an f of x or a g of x, so I'm just going to say a derivative of a function over a different function. F of x and g of x. I'm not going to write the x's because it gets really horrendous with the notation. But derivative of a function over a different function, this turns into g times f prime. So g times f prime. And this is going to be subtracted by f, yep, times g prime. It's not of, it's times.
I meant times.
I knew you did. I was just correcting our speech. G prime. All of this divided
You
by
want to rant to me?
Or like,
How dumb I am?
no.
our function g to the power of 2.
So gotta memorize that.
Like,
Gotta memorize this, but this is not the one you want to memorize. I'll give you the cutesy one that's easier to memorize. I want to make a note here. This is pretty critical. A lot of people try to just foil this guy out. I'm gonna say don't foil. So
So don't ever foil that.
don't foil the bottom. Don't factor, maybe another word. Don't foil the bottom.
Wait, this looks like something we've already done.
better than saying bad.
This formula?
Yeah.
Yeah,
My
it does.
favorite word.
That's a good point. What does this look like?
I
Oh,
try
one we
this?
learned yesterday.
F
Oh,
of A
God,
minus F of B.
No,
I'm scared. I don't know what to do.
No.
Yeah, you're thinking of average rate,
Yeah.
Rosalie. But yeah, Sophia, yesterday's lesson is directly tied into this. This is very similar.
Oh.
All right, are you guys ready for the cutesy version that you have to memorize?
Wait
Yeah.
1 second.
Oh, I don't like
Hold on, not for the recording, guys.
What?
Not for the recording. Thank you. We'll do it afterwards. All right, so the derivative of high divided by low is low d high
Lodi high.
minus high d low.
I know.
Hi, D-Lo.
Everyone feels like
Hi,
Ella's
D-Lo.
mom. Like, hi.
Who do they call D-Lo?
Divided by
Simba.
some people.
Everybody.
I shouldn't say some people. I should basically say everyone will usually say low low. But I'm just gonna put low squared. But pronounce this as low low because it's low times low, right? So
Lolo.
low di high, high di low. You always start with the low. You start at the low, but you end your day on that high. Low di high di low.
Today we're ending it on
Cross country.
I guess we're technically ending on a D low.
No.
It's
True
not
that.
ending. It's not ending there. It's on the beginning.
And I just
Say that again.
All right, let's do this like a kindergarten class. We'll pronounce this guy. So again, it goes like this: low di high minus high di low divided by low low.
Lolo.
Okay, on 3. 1, 2, 3. Low di high minus high di low divided by low low. All right, we got it.
Let's make a rap out of it.
I like
All right.
Language.
That is all that I have for you guys today. That's it. So you guys want to apply it to this function?
Yeah.
Yeah.
All right, so let me go ahead and copy it down here.
Wait. Low, D high, minus high D low, divided by low, 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 low.
Really good.
All right,
I should be Julie Harris rapper.
let's do this problem. So I'm taking the derivative.
Like, you know how we used to do like rap
Rap
battles?
Derivative of 2x minus 1 divided by natural log of x.
It's just another.
You could have just asked us. We had them on our paper.
All right, so
Bottoms up.
how do I do this? Let's apply the rule. Low d high. So low is, this is equal to, low is what? Tell me what to write.
Natural log
Natural log of x. And I don't like writing this the dot because I'll get confused what my terms were. I'm going to do parentheses here again. Times D high.
2.
You use 2x as the high, and then you take the derivative of that.
Exactly. Yep, you got it, Sophia. Minus, and someone new, tell me what I'm doing.
ln of x squared.
2x minus 1.
It's not ln of x squared yet.
And then
Oh, we're
times
not dividing.
1 over x.
Ah, yeah, very nice, Caitlin. Times
Ah,
1 over x.
you gave me pussies.
All of this is divided by Lolo, which is
X squared, L of x, or log squared.
natural log
God, I can't talk.
Natural log x squared.
squared. And then we'll simplify this a little bit. So this is going to be 2 natural log minus
I hate doing this.
2x minus 1
Oh.
divided by, or over x. And then all of this. Okay, that was a weird line. Let's try again, Mr. Sindel. Here we go.
What about the x for natural?
Where's
log?
the
The x.
Oh, whoops. Thank you.
Ooh, that's a point.
That's a point. All right, I'll write it down. Natural log of x
Imagine
times
if they didn't have points.
natural log of x squared. Just leave it squared. Don't foil
I thought
it.
that's what you were going to do when you first got here.
Yeah, I remember
You
you
said
didn't like
it.
points.
All the points.
You know what I don't
Write
like?
it
I
down.
don't like the simplifying. I feel like it's screws
Me
up.
too.
Me too.
Oh yeah, and Joy had one from yesterday
You know
too.
what I also don't like is when you have like 3, like a fraction on a fraction. Like it's kind of like
Yeah.
bothering me.
All right. So that is, now we've done an example. That is all the notes. We can go ahead and write our summaries as long as there are no more questions. Do we have questions before we begin our summaries?
Well, I just want to kind of say goodbye to our friends.
All right. Say goodbye, everyone.
Just
Bye,
have fun in
friends.
high school.
Bye, friends.
Live every day like it's
High school starts.
Live every day like it's your last.